Hey everybody, this is Mr. Longo, and this video is going to cover some function evaluating and some compositions. Something that you are probably familiar with by now. It is review of Algebra 2 Trig. But what we are going to do is refresh your memory. So the first example, we are evaluating with numbers. So when it says g of 5, what you're doing is substituting the 5 into your x's and then evaluating. So we would plug 5 into parentheses wherever we see an x. That's just a safe way to do it. And then you come up with your number. If you're allowed to use a calculator, you can type that right in, but 5 squared is 25, minus 5 is 20, plus 2 is 22. So it's not difficult to do. If you would like to try the next two on your own, go ahead and pause the video and see what you get. So for g of negative 2 squared is 4, minus a negative 2 turns into plus 2, which is 6, plus 2 is equal to 8. And then the last one, of course, 0 times itself is 0, minus 0 is still 0, plus 2 is equal to 2. So that's what you should have got for the next two. The next example, we are working with substituting in something other than a number. So finding f of negative x means we're just changing all of our x's to a negative x. And this is going to be something we apply to another skill in the very near future. So negative x squared still becomes positive x squared. So we have 2x squared. Negative 3 times a negative x turns into plus 3x, and then of course we have our plus 4, no big deal. When the negative is in front, that means we're multiplying the entire function by a negative. So that we're just going to distribute, and we're going to have a negative 2x squared plus 3x minus 4 after we distribute the negative in. Okay, and that'll just give us a completely opposite function. And what you're going to learn in the near future is if you substitute in a negative x and you get something that looks like that, it's going to be a certain type of function. Stay tuned. Okay, so performing operations or composition of functions and stuff like that. There are two different notations that you need to be familiar with. That means the exact same thing. So you can say f of x plus g of x, or you can say f plus g of x. Those are both the exact same types of questions. All we're asking you to do is add those two functions together. Now, as I mentioned before, parentheses a lot of times is very helpful. When you're adding, it's not that big of a deal, but it's safe. So x squared plus 2x. Plus, now we're going to add the function g, which is x minus 2. And now we're just going to combine our like terms because it's addition. So x squared, and then we're going to add those two together. 2x plus x is 3x. And then, of course, we have our minus 2. But the directions also say state the domain just for you to practice what we talked about before with domain. So you can square a negative 0 or positive. You can multiply a negative 0 or positive by 3. So this, our domain, is x equals all real numbers. Okay? So why don't you try the next couple if you'd like, just to see if you remember how to subtract, multiply, divide, and do a composition. Otherwise, if you want to keep watching, let's go. The second example is subtracting. This is why I said parentheses are helpful, because if you don't use parentheses, there's a good chance you're just going to subtract the x. But what we have to do here is distribute that negative into both parts of g. So this becomes x squared plus 2x minus x plus 2, giving us x squared plus x plus 2. If you didn't use the parentheses, there's a good chance you might have just subtracted the x. Okay, so now to talk about our domain here. Again, you can square a negative 0 or positive, same with add it. So this is going to be x equals all real numbers again. Now, for all of these examples, for the most part, we're going to have all real numbers except for one of them, which you should notice in a minute. F of x times g of x, or f times g of x, either way, it's the same thing again. This is just going to be foiling, because we have x squared plus 2x times x minus 2. So again, for this one, we must FOIL or double distribute, whatever you've done before. That's going to give you x cubed minus 2x squared plus 2x squared and minus 4x. That, of course, is going to simplify to x cubed minus 4x. In terms of our domain, there's nothing to worry about, so x is equal to all real numbers. Fourth example is where we have an issue with the domain. The whole division part to begin with, f of x divided by g of x, that's just going to be x squared plus 2x divided by x minus 2. Now, to simplify, don't you dare cancel any x's or 2's. You cannot do that unless it's the exact same. One thing you might have noticed on the top is you can factor out an x, leaving you with x times x plus 2 over x minus 2. Now, if the top was an x minus 2, or the bottom was an x plus 2, you would be able to cancel that and just have x. But you can't. So your domain for this one, remember, you can never divide by a 0. So the trick is you set denominators not equal to 0, meaning x cannot equal 2. Okay? Then we have our last couple examples. The first one, you might remember from Algebra 2 Trig, is a composition of functions where you're substituting an entire function into the other one. We say it's f of g of x, or you could do f of g of x. And what we're going to do is we're going to substitute the entire g function into f. So wherever you had an x in f, we're going to write parentheses. So that would be x squared plus 2x. And now what you're going to do is substitute the entire g function, x minus 2, into both places where you had an x. And then you're just going to complete this by simplifying. In this case, we need to FOIL x minus 2 with itself because we're squaring it, giving us x squared minus 2x plus 4, plus distribute our 2x minus 4. And then we just need to combine all of our like terms. So that's going to give us x squared minus 4x plus 4 plus 2x minus 4. And that's going to give us x squared minus 2x. We have no issues. So again, our domain is x is equal to all real numbers. Okay? And now the last thing we have to do here is an evaluation of composition of functions. So when you're doing f of g of 5, you could actually just do f of g of x, but a lot of times it's easier to just do one step at a time. So we're going to try to find f of whatever this is. So the first thing you should do is just g of 5. That means you plug 5 into any x, so that's going to give us 5 minus 2, which of course is 3. So now instead of this being f of g of 5, we know g of 5 is 3. So what we're doing here is f of 3. So now we take our f function and we substitute a 3 into any place that has an x. 3 squared is 9 plus 6. That's going to give us 15. So f of g of 5 is equal to 15. Now one thing you need to remember, whenever you're substituting in a number to a function, you better be getting a number at the end. You shouldn't have any x's laying around in your final answer. Okay, that's it for this video. This is Longo and I'm out. See you, bye.